So before we start to continue, let's summarize what we learned so far. So using CMake GUI, you can control the compilation process and settings. After you set the compile environment using CMake, then you can compile using make command. But when you use the make command, you have two major options. The first one is the just compile using default option. You can just type make to compile. But if you compile, if you use the make command with -J option, and using this option, actually you can use multiple thread, so you can speed up your compilation process. So for example, if you type make space -J8, this means you can compile using 8 parallel thread. So compilation is much faster. So let's try using make -J8 command. Let's try this first. Okay, so let's type the command and let's do the compile. So far looks okay. So it's making library files. But the compilation was not successful. So let's check the last error message. So if you see the screen, as you can see from screen, you see the blue letters. It says 70% completed CASADI. I think this is one of the library. So after CASADI completed, then after that it did something, but it failed. So I assume that after CASADI something went wrong. So let's go to the CASADI's folder and let's check what's inside. So if you want to move the to another directory in Linux, you can use cd command. But before you do this, let's check how many directories are in the Opensim -core-dependencies- build. So to do that, you can type ls, then you can go to CASADI, cd space CASADI, then let's type ls and let's check what's inside. If you go CASADI directory, then go to subfolder name build, build, and in this folder, if you type ls, then you can see what's inside this build folder. And as you can see, the CMake GUI set all the compilation environment inside of this folder. So in here, you can just simply type make, then you can compile only the CASADI library. So let's compile this CASADI library only, and let's see the compilation result. If this is compiled well, then I think CASADI does not have any problem. The problem is in somewhere else. So I think compilation for CASADI done well, because you can see the 100% build. So it's not CASADI's problem. So, but let's go back to the previous folder and let's do compile again. So it's not CASADI's problem. The problem is somewhere else. So if you try to build the Opensim core dependency build again, you still see this error message. So I guess the error is in somewhere else. So let's try to investigate. So using the gedit, open the make file. This is the CMake store all the compilation environment. So this is the the configuration done by CMake. As you can see, so now stop let's pay attention on the screen. So in the screen, let's pay attention the pink colored word. So this is all the dependencies and let's pay attention one by one. So these pink letters are all the dependencies, and as you can see, CASADI is in the last order. So CASADI, so if the compilation was done in serially, CASADI should be compiled in the last order. So if CASADI compiled well, that means everything compiled very well. But I still see these errors. That means this compilation was not done in serial. So as you know, we use the -J8 comment when you use the make comment. So this make the process parallel. So everything was not done serially. So if you use this parallel thread, it's good to finish the compilation in within short time because it uses parallel thread, but it is not good for debugging. So let's not use this parallel threading. Instead, let's use the serial compilation. So let's do it again using the serial compilation. Okay, let's do the compile again, but instead of a J8, I will just delete this -J8 option because it just keep giving us this error message. So let's stop using the parallel threading. So instead of parallel threading, let's just use default make comment. So without -J8, you can just type make without the -J8 option. So let's try it. So now compilation was done in serial order. So when you see error message during serial compilation, you see the real order where the error happened. So it happens during the compilation of EZC3D, and the error message was CMake's version program. Please pay attention the yellow circles I highlighted. So it is saying that CMake version required is 3.8 or higher, but I'm running version 3.5. So my CMake version is too low, so that's why error happens when the compiler compile EZC3D library. So now I found the reason why. So I need to upgrade the CMake version from 3.5.1 to 3.8 or higher. So let's do this. Okay, let me first check my current CMake version is really 3.5.1. So let's just type CMake. Oh, so spelling is wrong. I should type a small letter. Okay, then CMake dash version, that it will show my version. Yeah, the compiler says correct one. My version is too low, 3.5.1, and compiler need 3.8 or higher. Okay, so let's pay attention what I typed in the screen. So I use 4 words. The first word is sudo. That means I'm the super user. Super user is doing this. So that means I'm giving some root administrator's privilege to this command. So you have to do this whenever you install or remove any package. So let's use sudo command, and after the apt, this is related to the software install and remove. Then after that I type remove. So instead of install, I use remove. That means removing the software I want. Then after that I type cmake. This means I want to remove cmake. So let's use this command in the screen and just hit enter, and let's see. This is how you can remove the current cmake version. Okay, just type yes to continue, and then let's just wait. So it will remove all the components for current cmake. After you remove the current cmake, go to cmake website by typing cmake.org/download, and just look for the required version of the cmake from cmake website, and you can manually download from here and manually install. So just look for the version you would like to install. Let's look through all the list, and there are many versions there are many versions available, but I just wanted to check some older version. There you go. So I just found 3.8. So let's just download 3.8 installation file. There are various of installation format, but I will download SHE extension .SHE. This is one of the script for bash, and I think bash is one of the way I know, so I will choose .SHE format as .SHE extension. Okay, so I just downloaded .SHE. Then open your terminal. Then in the terminal, just look for type ls to see the file. Then sudo bash, and let's execute the sh file. So I just executed the .sh file using the bash command, and just read every description the software say, and when the software asks whether you to accept the license, just yes. But before you say yes to anything, you actually have to agree the any license term that the software provided. If you agree, then say yes. If you don't agree, just say no and stop the installation. Okay, so let's continue. Now the software is asking whether I want to install the cmake in download folder. This is the folder where I downloaded the cmake installation file, but no, I don't want it there. So you have to move stop the installation, and you have to move to the upper folder, then the download, and I suggest you to make a folder named cmake. So because if you install your cmake in download folder, it's too confusing, because you eventually gonna download many files in the download folder. So I suggest you to make your a folder cmake _3_8_0, and do it again in this specific folder, so that you will not be confused when you use the cmake file. So let's do it again in the new folder, then do the installation again. And this time, if the program asks you to install the CMake folder in the CMake underbar 3 underbar 8 underbar 0, then just say yes. This is where you wanna install the CMake program. Okay, now you just say yes. Then the software will be installed at the folder you specified, which is CMake underbar 3 underbar 8 underbar 0. Then program will make a subfolder named cmake-3.8.0-linux-x86 underbar 64, and program will extract all the file to that subfolder. So you see that the unpacking finishes successfully, so it's done well. But please pay attention in current screenshot. So I just typed cmake space dash version to check the CMake version, but please see the message you can see from the monitor. It says the program CMake is currently not installed. I just installed CMake 3.8.0, but computer does not recognize it. I will explain why. And let me before I explain, let me just type // and CMake and see the result. Pay attention to the screen. Okay, did you just see? After I type /CMake, then it worked. So there's a difference between just CMake and /CMake. I will explain. Okay, so let me explain what is the difference between /CMake and just CMake. So if you type // CMake, then computer recognize this is a local command. But if you just type CMake, computer recognize this is global command. So for example, in here, // means current folder. So // space CMake means execute CMake in current folder. So that's why the Linux recognize the CMake, because the folder you see in the screen is the folder where CMake is installed. So it works well. But if you remove // this means global command. So computer distinguish between these two commands. So if you just type CMake, computer recognize it as a global command. But if you want to use CMake as a global command, actually you have to register the path of the CMake to Linux. Otherwise, Linux cannot recognize. That's why you cannot launch the CMake by just typing CMake. Now you always have to use // space CMake, and it only work where the CMake is installed. But sometimes you may want use the CMake command in any folder in your Linux folder. So that's why you have to register the path of the CMake software. So let me show you how to do this. Please go to the highest folder in your Linux, that is home. So by using the file software, just go to your home folder. Then in here, let's open a terminal. And if you type ls, you see all the files in here. And make sure you you are in the highest folder and type gedit, and you see the comment from the screen. This is the way you can edit the basic environment file called BASHRC, and just open this file, and in this file you have to define your CMake as a global comment. So you can define the path of CMake in this file. So Linux will recognize this. Then you can launch a CMake program in any folder in your Linux folder. So in another word, it is called alias. So alias is a shortcut that references a comment. So in another word, it is called alias. So what we are doing here is making an alias for CMake. So to do that, actually you have to edit a file called .bashrc, and this is located in the root folder. So to find this folder, you have to go to you have to use the tilde mark. So tilde / dot bashrc. This is the location of the file that contain the environment of the your Linux environment variable. So to edit this file, you have to use I recommend you to use gedit. So simply in the terminal, you can type gedit space tilde / dot bashrc. Then after you open this environment file, simply you can add the path of the CMake. So you can use the command in fourth line of this screen. So you can use export space path equal $path colon. Then after colon, you can enter the path of the CMake file is located. Then after you finish adding this path in your file, then simply save and reboot your Linux. Then the alias will work. So let me show how to do this. So go to your root directory and type gedit space tilde / dot bashrc, and you see this all the environment setting for your Ubuntu, and in here you need to add the path of CMake. So go to file and go to the directory where the CMake software is located, and I suggest you to just copy this location and simply just paste the location of CMake to this bashrc file. Then you can just save the file, then close the gedit. Then in terminal, you just use source command to update your environment. So now if you type CMake can work in any directory. So now you see that the alias is working very well. So after CMake is reinstalled well, let's make sure that I have all the enough environment to compile. So just want to check the make version again. So I just type make -- version to see my GNU make version, which is 4.1. Okay, then I just type make comment to compile it again, but I got some error, so I better delete all the files made by previous version of CMake and delete everything, and I will compile from the beginning again because I just reinstalled the CMake. So let's do this. I will just go to the root directory and using the file manager select the files generated by previous version of CMake, and I will delete everything. Just delete, and let's do this again because I just updated the CMake. So let me check. So just type CMake -GUI and check all the environment, and let's do this again. So yeah, using CMake, just follow all the instruction that the Opensim website says. So let's go back to the Opensim website and just follow everything what the website says, and let's do this again. I just updated the CMake version, so let's make the setting again. Yeah, I'm just showing how I set everything. So I'm just repeating the CMake GUI setting again. So if you don't want to watch, you can just skip this section. I'm just repeating how I set the CMake GUI for Opensim core dependency build. So I'm just following the direction from the Opensim website says. So then configure, yes. Okay. Then I will just click these options. I will just click everything, and I will just set debug mode. Okay, and let's generate. So I'm just doing it again because I just updated the CMake version. So as you can see, the 3.8.0. Okay, let's just do this again. Okay, let's go to Opensim Dependency build website, and let's do make again. So I'm just compiling again using a make function. This time I will not use any parallel threading because I am doing debugging. I need to figure out what happened. So I will not use any parallel threading. So I don't see any more errors related to CASADI library. So now the compiler is compiling another library, and I don't see any error from CASADI library. So I think the thing we had a problem because of the CMake version has been fixed. So we are now compiling next library. So everything looks okay so far. So I think the compilation problem related to CASADI has been fixed. Yeah, I'm just showing the compilation result, and if you want to save time, you can skip this. I'm just showing what the compiler is doing. So compiler keep making library files. I think it works well so far. Okay, so I don't need to show you every compilation process, so I will skip this procedure and I will just show you the final result. Okay, I will stop my video here today, and in next video let me continue. Thank you for watching.